moon of the week, and this week it's Saturn's moon Enceladus, which has become the focus of much attention in recent years because of the discoveries made by NASA's Cassini probe. And we're going to just have a look at this moon. So first of all, just some basic facts about Enceladus. It's the sixth largest moon of Saturn. It orbits between Tethys and Dione. You can see there. That's where it is in relation to the other moons. So it's one of the inner moons of Saturn. It's got a diameter of more or less 500 kilometers. It's not quite spherical, so that the pole-to-pole diameter and the equatorial diameter do actually vary, although not by much, but it's not an exact sphere. It's got a surface temperature of minus 198 degrees Celsius, which makes it incredibly cold, obviously. And it was discovered in 1789 by William Herschel. It has a very high albedo of 0.81. The albedo is the amount of light that is reflected off it by the sun. So it is incredibly bright, and until the space age, it was never really clear why this moon was so incredibly bright, because it reflects nearly all of the sun's light. It orbits actually in one of Saturn's rings, the densest and the most diffuse part of Saturn's E ring. And you can see the E ring there. The rings of Saturn are given letters, and that's the E ring. And it was imaged first close up by Voyagers 1 and 2. This is a Voyager 2 image of Enceladus. Now, after the Voyagers, scientists were left with two questions, really. The first thing that you see when you look at Enceladus, you'll notice that it has a varied terrain with some cratered areas, but the rest of it is very, very smooth. And the fact that it's very smooth indicates that it's a very young landscape. So the question they asked, well, why are there these two types of terrain? Why is there a cratered area and a perfectly smooth area? How did that happen? And also they were intrigued by the fact that Enceladus does orbit within the densest and the most diffuse part of the E-ring. And these were questions that astronomers really wanted to know the answers to. And it had to await the arrival at Saturn of the famous and much missed Cassini probe, because Cassini discovered that, in fact, Enceladus is venting large amounts of water and water vapor and ice from an area near the south pole of the moon. And this is a false color image, but you can see there that there's a lot of activity going on there. And these plumes, Cassini discovered, were found to originate from fissures in the south polar region, which were nicknamed tiger stripes. And there you can see emissions coming from those tiger stripes towards the south pole of Enceladus. And that's where they are in the yellow box. Those are the tiger stripes, sort of parallel fissures towards the south pole. And this was a complete revelation that nobody really expected to see this activity on this moon. Here's a close-up of those tiger stripes, and you can there's actually one closer. And this is a Cassini image, and this is, I think, really dramatic image of one of those tiger stripes. And obviously, this is something that was not well understood. Here's a lovely image of a backlit Enceladus, where you can see quite clearly that or those plumes of material emanating from the tiger stripes. And here's a close-up that Cassini did. And, that material is very bright, indicating a lot of ice in it that's reflecting sunlight incredibly. And this, of course, explains the albedo of Enceladus, because some of that material falls back onto the surface to coat the whole moon in ice. But some other quantity of that ejected material escapes into space, where it actually forms the E-ring. So what Cassini discovered was that the whole of the E-ring consists of material that has been ejected from this little moon Enceladus. And there's a lovely image showing that quite clearly with Enceladus in the middle and that arc of material in the E-ring. So this was the first time that a moon near Saturn certainly has ever been seen to act in this way. It's a really, really active moon. And here's an artist's impression of what it might look like if you were actually there. I think that's a lovely painting, and it really does give the impression of that incredible activity going on at the surface. Here's a time lapse of Enceladus when Cassini was approaching it, and you can't miss what's happening there. And here's another one receding from Enceladus with those plumes really brightly illuminated, reflecting a lot of light. So here's what astronomers think is happening. As Enceladus has an icy crust, which isn't shown to scale here, but it's thought to be about 5 kilometers thick. And beneath that ice, there is thought to be a global ocean. So Enceladus is in fact a water world, as are many other or several other moons in the solar system, beneath the global ocean. And nobody knows how deep that global ocean is, but Enceladus is thought to have a rocky core. And that material from the ocean is spurting out of the tiger stripes towards the South Pole. Now, the exact mechanism for that is shown here, that you have tidal heating coming from below, and the water rises through cracks and becomes partially melted below the surface, below the crust, and eventually expands and it vents to the surface, and the melted ice drains back into the ocean from those sort of reservoirs. Now, what happened with Cassini is that the mission managers and the engineers came up with an amazing adaptation of Cassini to enable it to fly through one of those plumes to actually analyze what was in the plumes. And it did this a few times. The first time was on March the 12th, 2008. Cassini dipped low to fly right through one of those plumes and sampled it and analyzed what was in the plumes. And there were lots of surprises in the plumes, because in the plumes there was a lot of water, which is being ejected at about 300 kilograms per second from the tiger stripes. There was crystalline ice. Ice on the Earth doesn't form these types of crystals that we find on Enceladus. There's methane, there's oxygen and nitrogen bearing organics, carbon dioxide, molecular hydrogen. So this is a real sort of potpourri of chemicals that are being ejected from the tiger stripes. And there are also rock fragments in which they found silicon dioxide. But some of those elements, if you like, some of those chemicals had been in contact with rock. So they definitely had come up through a liquid environment and ejected into space. And this is, another good reason for believing that there is a global moon beneath that icy crust of Enceladus. And here it is in a little more detail. Astronomers believe, or planetary scientists believe, that on the ocean floor there might be things that are analogous to the black smokers along the mid-Atlantic ridge on Earth, this geothermal activity. I'm sure you've all seen videos of the black smokers. And on Enceladus, because of the ice, of course, they will be white smokers. And there you have, as I was talking about, water-rock reactions, which they found in the plume, the particles they found in the plume, the hydrothermal vents leading to the surface jets. So just to summarize all that, Enceladus is an active world with its interior heated by Saturn's gravity, so-called tidal heating. It actually has the purest water ice surface of any body in the solar system, and of course that's constantly being replenished, which explains why the surface is so young and why there are so few craters, because the surface is constantly being resurfaced, if you like, with all of that material falling from the plumes. It has a global underground ocean, and the chemicals and the water vapor and the ice and everything else and the gas actually creates Saturn's E-ring as Enceladus moves round in its orbit around Saturn. And its ocean floor may be home to geothermal features like the black smokers along the mid-Atlantic ridge on Earth. And of course, all of this makes Enceladus a prime candidate for the possible existence of life on this little moon orbiting Saturn. So there you are. That's the moon of the week.